Hello students, this is Pharma College for third year management students for the course Operations Research. Today we are going to start the second chapter, that is linear programming model. Therefore, after completing this chapter, you are going to define what linear programming is, and also you should discuss the structure of linear programming model, application area and solution method, and explain the complication and the solution for this linear programming model. Therefore, when we come to the definition of a linear programming model, it is a mathematical technique for optimal allocation of resources, therefore, which it can be to maximize or minimize the resources. In linear programming, there are two models, there are two objectives, either maximization or minimization. And also the other one is characteristics of linear programming model, which is related with component and assumptions, whereas the component is the structure of the model, whereas the assumption is revealed the condition under which the model is valid. So it is very important to consider the components of the linear programming model. The first one is the environment, the second one is the decision maker and a set of decision variables, the objective function and a set of constraints. And also you should consider these are the four basic assumptions of linear programming model, which is the first one is linearity, which is related with the requirement of the decision variable with a linear impact on the objective function. The other one is divisibility, which this assumption pertains to the potential values of the decision variable. Here non-integer values are acceptable, whereas the certainty related with all parameters of the problem are fixed noun constant, and non-negativity, which is assuming zero or positive values. Therefore, there are different applications of a linear programming model. As you can see from this PowerPoint display, there are personal assignment can be solved through linear programming model, transportation problems, efficiency on the operation of system of dams, on agricultural application, military application, and the physical distribution. Therefore, the first advantage of this linear programming model is optimization, to optimize the utilization of productive resources so as to make a best decision. And in formulating a linear programming model, there are basic five, or it depends on the different scholars' work. Therefore, the first step is define the problem. The second one is identify the decision variables, and the third one is formulate the objective function, and the last one is writing the constraint and the completed LPM model. Then to start with first here maximization example, assume that Philips Corporation produces two types of TV sets, model A and model B. The profit realized from model A and B are 300 and 250 respectively. The company wants to produce and sell 1,000 TV sets daily, but this is not possible due to some limitation. Therefore, the limitations are there are only 40 hours of labor, there are only 44 hours of machines in each day, and the maximum that can be sold of model A to be sets is 12. Therefore, it is known that each set of model A being higher in quality requires 2 hours of labor, and each set of model B requires only 1 hour of labor. Therefore, the machine processing time for 1 unit of model A and the model B are 1 hour and 3 hours respectively. If the company objective is to maximize profit, this is describing the model. Therefore, to describe the model, the first step is problem definition, that is to determine the number of model A, B TV sets to be produced daily in order to maximize profit. Step 2 is writing the decision variables, that let x1 is the number of model A TV sets to be produced, and x2 the number of model B TV sets to be produced daily, z which is related with total profit. And the step 3 formulates the objective function, which is maximization 300x1 plus 250x2. And the last one is formulate the constraints. Therefore, there are 3 constraints: labor, machine, and the marketing. Therefore, this is the completed LPM model, which is formulated based on the case. Therefore, maximize Z is equal to 300x1 plus 250x2, subject to these constraints. And when we come to the minimization case, let's see this the first example, the minimization case. This here, dietitian is preparing a diet consisting of 2 foods, A and B. Each unit of food A contains 20 grams of protein, 12 grams of fat, and 15 grams of carbohydrate, and it costs 4. And each unit of food B, 30 grams of protein, 6 grams of fat, 15 grams of carbohydrates and cost per serving. The diet being prepared must contain the following minimum requirement of at least 60 grams of protein, at least 24 grams of fat, and at least 30 grams of carbohydrate. And how many units is needed? Therefore, the objective is related with the minimization of the case. Therefore, the first step is problem definition. Therefore, the problem definition is to determine the number of units of each food to be used in the diet, minimizing the cost. Step 2 is representing the decision variables. Let x1 is the number of food A, x2 the number of units of food B, C is the total cost. Step 3, develop the objective function, maximize it for x1 plus 3 x2. Therefore, list is a constraint. Here is a completed LPM model that you can observe from this PowerPoint. Therefore, the next one is solutions to linear programming problems. Therefore, there are two methods, geographic and the simplex algorithm. Therefore, when we come to the geographic or the graphical method, there are 4 steps that you should bear in mind in order to provide a solution set for a formulated completed LPM. The first one is form a mathematical model, and the second one is graph each constraint, identify its region, and determine the region, and select the one with the highest or lowest value with the objective function depending on either the objective, that is maximization or minimization. Therefore, if the objective is maximization, you can select the highest value, whereas when it is minimization, we may select the lowest value. Therefore, based on this, for example, this is the completed LPM model. Therefore, find through graphical method, right? A completed LPM model. Therefore, you can take this the completed LPM model here. Step 2, graph the constraint. Therefore, to graph the constraint, you can let when x1 is 0, you can find the value of x2, which is clearly 20. When x2 is 0, then x1 will clearly be 10. Therefore, these are the coordinates of the first constraint, x1 and x2. When we come to the second constraint, which is 2x1 plus 4x2 less than or equal to 32, you can change this inequality to equality and let x1 0, then x2 8. When x2 is 0, x1 16. Therefore, the coordinates are here. Therefore, now you can graph. Therefore, this is x1, which is this is x1, whereas this one is x2. And now you can graph these constraints. Therefore, when x1 is 10, x2 is 20. x1 is 10, x2 is 20. When x1 is in the second constraint, when x1 is 16, x2 is 8, x1 is 18, x2 is 8. Now you can find the common region, and at point A, the coordinate of x1 and x2 is 0 and 8. You can find through observation, and putting these values in the objective function, you can find the total value, that is 440. In extreme point B, it is very difficult to find the values of x1 and x2 through simple observation. Therefore, better to undertake a simultaneous equations, and through undertaking a simultaneous equations, you can find the values x1 and x2, 8 and 4, and the total value will become 860. When at point C, the coordinates are 10 and 0, you can find you can determine, or you can find the values of x1 and x2 at point C through putting this x1 and x2 coordinate in the objective function, the value 800. Therefore, the maximum value is 860. And now the optimal solution is found. Therefore, the coordinates of at point this is x1 is 8, x2 4. The profit is in 816. Therefore, this is the end of chapter 2. Therefore, in the next session, we are going to see the transportation assignment problem. Thank you very much for your stay.